Hi everyone, welcome back to my YouTube channel. So in this class we'll be solving a series of questions on matrices. So we'll look at this first question, which tells us to evaluate these two matrices. So if you see the kind of brackets or the type of matrix being used, it tells us that we need to find the determinant of these matrices. So starting with the first one, we're going to use the normal method of just solving the determinant of a 3 by 3 matrix. So that is with the concept of having that here it's positive, here negative, and here positive. We'll be taking, if we pick this number, then we'll eliminate this column and also this row. Then we'll pick our determinant from these 4 elements, and just like that, if we come on the middle, we'll eliminate this row, this column, and also this row, and then we'll pick our determinant from these side by side elements, and just like that. So let's start. So our first element is 1, so we'll say 1, then we collect our elements. So just for sure, if we've picked from this element, so that means we'll more of erase those elements. Then we'll pick from, so that means we'll have what will be left is cos x sin x minus sin x cos x, like that. Okay, with a different marker. Okay, then we're on the middle element. So if you look at this this coming element, it's having 0, so which means if we were to solve it, of course the element here will just be 0. So we'll just say positive, because we can't say negative 0, because 0 will come and multiply whatever we have in here. So this will be 0. And the same will follow for the other element if we reach this end. If we are here, if we're on 0, we'll delete this. So we'll have these elements multiplying. So this is also another 0. So it's okay even if we don't also solve it, because this will also just be, it will result in 0. We'll have 0. So the only element which passes is this one. I hope this is clear. So for this one, once we solve this determinant, we'll multiply with this one. And once we multiply, even here when we get our determinant, we'll multiply with 0. And then number multiplied by 0 is 0. So the same thing will be for this element. Whatever we'll have in this determinant, it will be multiplied with 0. So these are zeros. These two are zeros. So we won't consider them. So that means just picking from the first one, we'll have cos squared, cos x by cos squared, we'll have cos squared x, and minus, then sin x by sin x, we'll have sin squared x, which is a negative. And then multiplying the negative positive there, we'll have cos squared x plus sin squared x. And then looking at our trig identities, this is just 1. And we're done. Let's go to the next one. So the other question we had was, we also need to find the determinant of this matrix. So using the same principle of elimination, if we're starting with the first element, so that means we eliminate this this column and this row. Then we'll multiply cos y by cos x, and we'll subtract with sin x sin y with 0, which is just 0. So let's do that. So we're saying we'll have cos x cos y. This will multiply, so we'll do the multiplication. So we'll multiply this element with this element. So we'll have cos y by cos x, which is cos x cos y, then sin x sin y multiplied with 0 is just 0, so we can just maintain it like that. Then remember the rule when we're here, so this is positive, negative, positive, so we've come to this element in between. So here our consideration will be we eliminate this column and this row. So that means we'll multiply negative sin y with cos x, and we'll subtract with sin x cos y with 0, which is just 0. So let's do that. So since it's a negative there, so we'll write minus, so that is cos x. So we'll now multiply, so we're multiplying negative sin y with cos x. This will give us negative sin y cos x, then we multiply sin x cos y with this element which is 0. So this is just 0, so it's okay if we don't write it, it's just 0. Then on the last element, so we are here now, so with this part we're going to eliminate this column and this row, so that we can just multiply negative sin y with sin x sin y, and it follows that way. So let's do it. So this is negative sin x, so it will be here negative sin x, then we'll have the elements inside. So here we're multiplying negative sin y with sin x sin y, so we'll have a negative sin x sin squared y, then we'll multiply cos y with sin x cos y. So that is, let me write it here. So we're subtracting, so we subtract this side, so it will be minus. So I'm multiplying cos y with sin x cos y, which will give us sin x cos squared y. Then we can simplify what we've written. So if this one multiplies, if we have cos x, so that means we'll have cos squared x, and cos y, we'll have cos squared y. Then we'll multiply negative cos x sin y with this element inside. We'll end up having positive. Then like terms cos x and cos x will make cos squared x, and sin y will make sin squared y. So that means we'll have sin squared y cos squared x. Then multiplying here negative sin x with negative sin x sin squared y, so the like terms, so we'll have positive sin squared x sin squared y. Then negative sin x multiplying with this, we'll have positive sin squared x cos squared y. Then here we can factor out, just here we can do some factorization. Cos squared x is common, so that means we'll have cos squared x will remain with cos squared y plus sin squared y. Then we'll do the same on this other side. We'll factor out what's common. So here what's common is sin squared x. So that means we'll have sin squared x, then we'll remain with sin squared y plus cos squared y. Then here we can use the grouping of terms method, where we can just factor out, since this is common, this is the same thing, we can factor it out. That means we'll be left with, we'll have sine squared y plus cos squared y, and we'll have sine squared x plus cos squared x. And by trig identity, this is 1, 1, so that is 1, this is 1, just giving us 1. So our next question, we're being asked to find the value of P for which this matrix M is singular. So if a matrix is singular, you should know that then the determinant of that matrix should be equal to 0. So we're going to find the determinant of this matrix and then set it equal to 0. Then we can find the value for P. So we say determinant of matrix M will be equal to, so using the same principle we're solving, so starting at 3, if we eliminate this column and we eliminate this row, we'll have 2p multiplying with p. That will give us, so having 3 outside like that, so 2p by p will have 2p squared, then we'll subtract minus, then we'll have 2 multiplying with 1, that will be 2. So going over to the next element here, so remember taking the negative, so we'll have negative 1, then we'll open the bracket. So we're eliminating this column and this row. That means we're remaining with 1 multiplying with p, which will just be p, then 0 by 1, which is just 0, so we can just have this p. Then going over to the last element, or negative 3 here, so we'll eliminate this column and this row, so that we remain with 1 multiplying with 2. So remember taking the element there, which is negative 3, then we have 1 multiplying with 2, which is 2, and 0 by 2p is just 0, so we just have 2 there. Then we simplify this expression. 3, we multiply 3 throughout, we have 6p squared minus 3 by 2, that is 6. The negative 1 by p will be negative p. Then there we'll have negative 6. Then we can simplify negative 6, and negative 6 will give us negative 12. So we'll have 6p squared minus p minus 12. So the determinant of this matrix is equal to, so remember we had said if it's singular, then the determinant is equal to 0. So this is a quadratic, which is 6p squared minus p minus 12 is equal to 0. Okay, so this is our expression. So solving it using the quadratic, so use the quadratic formula. So solving the value for p, so we'll have negative b, positive or negative so replacing, we have, that's negative 1, so we just have 1, positive or negative, then we'll have just 1, negative 1 squared, so 1 minus 4, 6, negative 12, and then this is over 12, 2 times 6 is 12. Then we can just have everything simplified now. So 4 times 6 minus 12 will give us 288. So plus 1, 289. So I have square root of 289 over 12. Square root of 289 is 17. Then that means we'll have 1 positive or negative 17 over 12. Then simplifying it, so we have 1 plus 17, that is 18 over 12. And then we're also having 16 over 12. Then we can simplify dividing this one. So we can divide 6 into both. So 6 into 18 is 3, 6 into 12 is 2. And then here we can have 4 into 16, that's 4, 4 into 12, that's 3. So our values for P are P is equal to 3 over 2, or P is equal to 4 over 3. So these are the values of P, for which matrix M is singular. Something I've just missed is 1 minus 17 is negative, so this one will be negative, negative, negative. Okay. Go to the next question. So the last part of the question, the B part, says if we have M in this expression and we have P is equal to 2, they've told us to find the equation for the value of P is equal to 2. So we'll go back to our expression or matrix of M, then we replace 2, then we simplify and solve the equation. So our M matrix was, so our M matrix we had, so rewriting this M, replacing where there is a P, we put 2. We'll have 3. So since P is 2 and there is 2P, so we'll have 4, then 2, then negative 3, 1, and P will put 2 here as well. Then we're having X, Y, Z, and negative 7 over 2, 11 over 2, and 5. Okay, so we need to solve this equation. So we can use Cramer's rule since it's simplified. So using Cramer's rule for solving this, first we'll find the determinant, which we'll label as D. So the determinant of this matrix, using the same principle, we eliminate this column and this row, but we'll have 3 multiplying what we get inside. So 4 by 2 minus 2 minus 1, 2 minus 1, 2 multiplied with 1. So that is, we'll have 3, then 4 multiplied by 2 is 8, minus, then multiply 2 with 1, we have 2. So remember, we are still dealing with a positive, negative, positive. So on the next element we have negative 1 multiplying, so we eliminate this column and this row. So we'll have 1 multiplying with 2, that will be 2. Then this is 0, so we'll just leave it that way. Then there's a negative 3 there, so we're going with deleting this column and this row, but maintaining the pivotal point, which is negative 3. And then we'll have 1 multiplied by 2, that is 2. And then 0 by 4 is just 0, so we'll just maintain it that way. So 8 minus 2 is 6, 6 by 3 is 18. Then we'll have negative 2 there, then we'll have negative 6. Then this is 18 minus 2 minus 6, which is just 10. Okay, so solving for the first first determinant for x, we replace this whole column, with this solution here, and then we'll find the determinant, and that will be our determinant x that we'll start with. So let's do it. So that is, for the first column, we will replace with negative 7 over 2, 11 over 2, and 5. Then we'll maintain the rest of the elements. So we'll have 142. Then we'll maintain the rest of the elements. So that is 1, 4, 2, negative 3, 1, 2. Okay, then we find the determinant for this matrix. So we'll hold this column and this row, and then we'll multiply 4 by 2, then we'll subtract with 2 multiplied with 1. So while maintaining the element 7 over 2, so we'll multiply 4 by 2, that is 8, then 2 multiplied with 1, we'll have minus 2 like that, then minus 1. Then so we're here, we hold this column and we hold this row. So 11 over 2 by 2 will just be 11, minus 5 times 1, just 5. Then we have negative 3. So we hold this column and we hold this row. So that means we'll have 11 over 2 by 2 is just 11, minus 5 by 4 is 20. Then we simplify. 8 minus 2 is 6. Then we can have 2 into 6, that's 3. 3 times negative 7, that's negative 21. Then 11 minus 5 is 6. That would be minus 6. Then 11 minus 20 is negative 9. By 3, that is positive 27. Then we can simplify. Negative 21 minus 6, that's negative 27, plus 27, that is 0. So this one is 0. Then we also look for the determinant with reference to y. So that is d with reference to y. So if you see how we replace with the first column. So this time we replace these values on the middle column. So let's do it. So that means we'll maintain the elements that were on the first column initially, which is 3, 1, 0. So we have 3, 1, 0. Then on the middle column, that's where now we'll have negative 7 over 2, 11 over 2, and 5. Then the final column is just the same. So we find the determinant for this one. So maintaining positive, negative, positive. So we'll hold this column and this row. So that means we'll have 3. Then 11 over 2 by 2 is just 11, minus 5 by 1 is just 5. Then minus. So if on the next column, if we hold this column and this row, the pivot value is negative 7 over 2, so it will be positive 7 over 2, multiplying, so it will be 1 by 2, which is just 2, then 0 by 1 is just 0. So you can go to the other element, which is negative 3. So if we hold this column and this row, we have 1 by 5, which is just 5. 11 over 2 by 0 is 0. Then we can simplify. 11 minus 5 is 6 by 3, that's 18. Plus 7 over 2 by 2 is just 7. Negative 3 by 5 is negative 15. 18 minus 15 is 3. Plus 7, that is 10. So going to the last determinant with reference to z. So we'll write our matrix the way it was. So the first column will maintain. Then also the following column will also maintain. But we will replace on the last column. So that's why we replace our values of solution. So now finding the determinant for this one. So the determinant using the same method. So that is, this is positive, negative, positive. So we hold this column and this row. We'll have 4 by 5. So having 3 there, we'll have 20 minus 11 over 2 by 2 will just be 11 minus 1. So holding 1, this column and this row, we'll have 1 by 5, which is just 5. 11 over 2 by 0 is just 0. then minus 7 over 2 here. So this is our pivot point, so we'll hold this column and this row. 1 by 2 will just be 2, 4 by 0 is 0, so we just have that. So we have 3, 20 minus 11 is 9, and then we have negative 5, and then we have negative 7. 7 over 2 by 2, the 2's will just divide. So at this point, 3 times 9 is 27. Then negative 5 minus 7 is 12. So 27 minus 12 will give us 15. So this value here is 15. Then we can simplify or finalize now our solutions. So we'll say the value of x is equal to d of x over d, which is d of x was 0 over our d is 10, so this is 0. Then our y will be dy over d, which will be dy is for dy we got 10, so that would be 10 divided by 10, which will give us 1. Then z will be dz over d, which will be z is 15, so we'll have 15 over 10, which will just be equal to, if we reduce by 5, we'll have 3 over 2. And these are our values for expression, so we can just rewrite it just to find the equation. So that means rewriting our m in full. So our m is 3, 1, 0. Then we have 1, 4, 2. Negative 3, 1, 2. And then we replace our values for x, y, z, which is just 0, 1, and 3 over 2. So this is equal to negative 7 over 2, 11 over 2, and 5. So this is our final solution. Okay, so for this part we have solved the following system of linear equations using Cramer's rule. So I'll pick selected questions. So solve question 2, 4, and 5. Yes. So question 2. So we have this system of linear equations that we need to solve using Cramer's rule. So before we resolve them, the best we can do is make them into just okay, in a simplified, we can simplify them so that they look linear as it's stated. So that is, we can put a common denominator over here. So to solve this one, we can just put over 1, then we cross multiply. So cross multiplying it will give us 3x plus 2y plus 1 is equal to, then 4 multiply x, we'll have 4x, and then 4 with y, we'll have 4y. Then we can collect the like terms. So that is 3x, when 4x crosses, we'll have negative x, and then 2y minus 4y will have negative 2y, and then this will be equal to negative 1. And that's our expression simplified. Then we'll do the same here, we'll put over 1, then we'll cross multiply. So we'll have 5x plus 6y minus 7 is equal to, then 2 multiply x and 2 with y, so we'll have 2x plus 2y. Collecting like terms, 5x we subtract with 2x will give us 3x. Then 6y we subtract with 2y, giving us plus 4y, which is equal to positive 7. So we write in our simultaneous equations, we'll have negative x minus 2y is equal to negative 1, and we have 3x plus 4y is equal to 7. Okay, so from there we can write them in matrix form. So that is, we're having, picking the coefficients of the variables on the left hand side, we have negative 1, negative 2, then on the other equation we have 3 and we have 4. Then we have the variables, we have x and y. Then the solutions, we have negative 1 and 7. So we've written it in matrix form. Then we can apply the Cramer's rule. So with Cramer's rule, we'll first find D, first determinant. So the normal method, so negative 1 by 4, we'll have negative 4 minus, so negative 2 by 3, we'll have negative 6, which is equal to, this will be positive 6, which will just be 2. Then we can find the determinant with reference to x. So we replace our solutions on the first column. That means we'll have negative 1 and 7. Then, okay, I need to use a different marker. So let's try to maintain this color then. Negative 1 and 7. Then we're having negative 2. We'll maintain the other column, and 4. Then we find the determinant. So negative 1 by 4 is negative 4. Negative 2 by 7 is, so we'll have positive 14. So which is equal to 10. Then we also look for the determinant with reference to y. So this time around we replace on the second column. So here we'll have negative 1 and 3. Then on the column we replace the solution, so we'll have negative 1 and 7. Then we solve it. So negative 1 by 7 will give us negative 7. Negative 1 by 3 will have a positive 3 due to the negative when we subtract. So negative 7 plus 3 will give us a negative 4. Then we can now find the values. So that is x will be equal to, so d of x over d, giving us our d of x is 10, our d is 2, so this is 5. And then our y will be equal to d of y over d. So our d of y is negative 4, our d is 2, giving us negative 2. So we can rewrite our matrix as we represent the solution. So we had negative 1, 3, negative 2, is it negative 4? It's just 4. Then our solutions here we have 5 and negative 2. This is equal to negative 1 and 7. Then we've solved our expression. Let's go to the next one. So our next expression is this expression I've written on the screen. So we need to take it into matrix form. So that is, we'll pick the coefficients. So that is, we have 1, negative 2, 3. Then on the next we have negative 1. So y is 3. Then we don't have z, so that is 0. And on the other one we have 2, negative 5, and 5. So like that. Then So our variables are x, y, and z. Then our solutions are -1, 10, and -7. So our method of Cramer's rule, we'll find first the first determinant, d. So picking 1 as our first reference, we hold the row and the column of this element. We'll have 3 by 5, so maintaining 1 outside, so we'll have 3 by 5, that is 15. -5 by 0 is 0, so we'll just maintain it. So this is positive, negative, positive. So we'll have -2, but since it's negative there, so we'll have a +2 multiplying. So we hold this column and this row. We'll have -5 by 5. We just have -5. -1 by 5 is -5. Then 2 by 0. Then the last one is a +3. So we hold this column and this row. So -1 by -5, we'll have a +5. Then 3 by 2, we'll have a 6 minus 6, like that. So this will be 15. 2 multiplied with -5, we'll have -10. 5 minus 1 is -1. Then 5 minus 6 is -1 by 3 is -3. So 15 minus 10 minus 3, this is -13. So we'll just have a +2 as our d. Then solving for the determinant with reference to x. So we have d of x. So we write our matrix. So we place the solution on the first column. So that is, we will place here with -1, 10, and -7, which are our solutions. Then for the rest of the elements, we'll maintain. So that is -2, 3, and 5. Then we have 3, 0, 5, like that. Okay. Then we solve for the determinant of this matrix. So we hold -1 and the row there. So we'll have a -1 multiplying with 3 by 5, that is 15. 5 by 0 is still 0. So this is a negative here, so we'll have a +2 multiplying with, so we hold this column and this row. So 10 by 5 is 50. -7 by 0, it's 0, so we just maintain it. Then we have a positive, so a 3 there. So we hold this column and this one here. So 10 by 5 is 50. And then -7 by 3, that is -21, so it will be +21 there. So we add, so -15 by -1 by 15 will just be -15. 2 by 50, that will be 100. Then 50 plus 21 by 3 will give us 213. 213, yes. Then the addition of all this will give us 298. Yes, 298. That's our determinant with reference to x. We go for the determinant with reference to y. So for this one, so we're replacing on the middle column. So the elements will be maintained throughout. So we have -1, -1, 2. Then we're having so the elements on the middle, we are changing them. So we are putting the solutions to -1, 10, and -7. Then the final column will maintain with 3, 0, 5. Then we solve it. So we pick the first one. So we hold the column and the row. So 10 by 5 will be 50. -7 by 0 will be 0. So this is a negative, so here will be a +1. So we hold this column and this row. So -1 by 5 will be negative 5. 2 by 0, just like that. Then we hold for 3. So negative 7 by 7 there will be positive 7, minus 2 by 10 will be 20. So this will give us 50. 1 by negative 5 just be negative 5. 7 minus 20 will give us a negative 13. By 3 that would be 39. Yes. Then 50 minus 5 minus 39 will give us a 6. Okay. Then we solve our determinant with reference to z now. So here we're maintaining the elements negative 1, 2. We'll maintain all the elements, but we change for the last column. That's why we put our solution. Okay, so now let's solve it. So we start with 1, then we hold 1, so this column and this row. So we have 3 by negative 7, that's negative 21, minus, so then negative 5 by 10 will be negative 50, then so it will be a positive 50 like that. Then we have negative 2, so it will be positive 2 here. So we hold this column and this row, so negative 1 by negative 7 will have a positive 7. Then 2 by 10 will have a negative 50 there. So negative 20. 2 by 10 is 20, so negative 20. So I have a negative 1 multiplying there. So negative 1 will hold this row and this column. So negative 1 by 5 will have a positive 5. 2 by 3 will have minus 6 there. Will give us 29, positive 29. Then 7 minus 20 will give us a negative 13 by 2 to give us a negative 26. Negative 1 to 5 minus 6 will just have positive 1. Then when we add these, so this will give us 4. Okay, so now that we have all the values, we can solve each expression or each variable. So we have for x, so x will be equal to d of x over d. So our d of x was 298. So 298 dividing with d, our d is 2. So we divide this by 2. So 298 by 2 will give us 149. Then our y, our d of y over d, our d of y gave us 6. So we'll have 6 over 2, which will be 3. And finally our z, so d of z over d will give us our d of z is first 4 over 2, that's giving us 2. So therefore our x is equal to 149, our y is equal to 3, and our z is equal to 2. Okay, so that's our final solution. Okay, so we have this question. We need to use Cramer's rule to resolve it. So if you look at, these are fractions with variables. If we try to simplify, it will be very, very tricky. So we'll just solve it as it is. So that is, we'll write it in matrix form. So the first element is 4 over 3 then we have 1, then we have negative 3 over 5, and we have a negative 1. Then for the variables, we maintain them in fraction form, so 1 over u and 1 over v, and then this is equal to, so we have 1 and negative 1 over 6. Okay, so now we need to find the determinant, the main determinant. So we use the normal method. So 4 over 3 by negative 1, so we have negative 4 over 3. Then this is subtracting negative 3 over 5 by 1, so we just have positive 3 over 5 like that. Then if we solve this one, so that's common denominator, so 5 by negative 4 we'll have a negative 20, and 3 by 3 we'll have a 9, so everything is over 15, which will be equal to negative 20 plus 9. We'll have a negative 11, so we'll have negative 11 over 15, so we'll have a negative 11 over 15 as our D. Then we replace our solution on the first element for us to find 1 over u. So D of 1 over u will be equal to, so that is so solving for D1 over u, so we've replaced the solutions on the first element, then we maintain the other element at the other column. So let's multiply 1 by negative 1 will give us a negative 1, then minus negative 3 over 5 by negative 1 over 6. So if we divide 3 by 3, that's 1, 3 into 6, that's 2, so 10, so we'll have a 1 over 10. And solving this, that's 10 over 10, so that's just negative 11 over 10. Then we solve for D of 1 over v, which is equal to, so this time we'll maintain the first element, so that's 4 over 3, 1, then we'll put the solutions here, that is 1 over, it's 1, then 1 over 6 negative will be there. So then we simplify it, 4 over 3 by negative 1 over 6 will have, so we can divide 2 there, that's 2 into 6, 3, so that we have a negative 2 over 3 by 3, that's 9, so have a 9 there, then 1 by 1, so minus 1. So if we subtract the 2, which is just negative 9 over 9, giving us negative 11 over 9. Okay, so now we can find the values of 1 over u. So 1 over u is D 1 over u over D. So this is equal to, so D1 over u is negative 11 over 10. So we divide it with D. Our D was negative 11 over 15. Negative 11 over 15. So we simplify this, we'll have negative 11 over 10 times 15 over negative 11. So these divide, then 5 into 10, that's 2, and 5 into 15, that's 3. So this is our first value of 1 over u. So we're having 1 over u is equal to 3 over 2. So if we were to reciprocate this, we just have u is equal to 2 over 3. Okay, and this is our first value for u. Then we do the same for d, for 1 over v. So 1 over v is d 1 over v over d. So 1 over v we said is negative 11 over 9. So this is dividing with negative 11 over 15. So that is negative 11 over 9 multiplied with 15 over, so negative 11 there. So this can divide, then we can simplify 3 into 9, 3 into 15, so that is 5 over 3. Then we're saying 1 over v is equal to 5 over 3. So reciprocating this, we just have v is equal to 3 over 5. So finally, our values are u is equal to 2 over 3 and v is equal to 3 over 5. So these are solutions. That we need to show that the matrix A, this matrix satisfies this equation, and I is the identity matrix. So to show that, let's find A raised to 3. So that means we multiply A 3 times. So we'll start with, let's say A squared. We multiply A with A. So that means we're having 3, 0, 0, 0, negative 1, 3, 0, 2, negative 2. So we're multiplying this matrix. Okay. So multiplying this matrix will give okay, so the multiplication will go with row by column, row by this column, row by column, just like that. So let's begin multiplication. So 3 by 3, that's 9. Then 0 by negative 1, that's 0. And this is also 0, so we can leave it that way. So that means we're just having something like 0 plus 0. So we cannot even write it. Then we'll have in the other column, so we'll have 3 by 0, that's 0. And all the rest are zeros. So this is just, these are all zeros here. Then again we'll have 3 with this whole column. So 3 by 0 is 0 and the rest are zeros. So we're having a 0 again in the following column. Okay, then we start with this row with all the columns. So 0 by 3, that's 0. And the rest are all zeros. So we just have a 0 here. Then we'll have again this row with the following column. So 0 by 0 is 0. Negative 1 by 1, that's, so we have a 1 plus. And then we have 2 by 3, that's 6. So we have a 6 there. Then the same row, this row with this column. So that means 0 by 0, that's 0. Then negative 1 by 2, we'll have a negative 2. And then 2 by negative 2, we have a negative 4. Okay. Then we're down to the last row with all the columns. So 0 by 3, that's 0. And the rest are zeros. So we'll just have a 0 here. Then 0 by 0, it's 0. 3 by negative 1, we'll have a negative 3. Then negative 2 by 3, that's negative 6. Then this row now with the final column here. So 0 by 0, 0. 3 by 2, we'll have 6. And then negative 2 by negative 2, we'll have a positive 4. Then we can simplify this matrix. So the first element is 9. We'll have a 0, a 0. Then we'll have a 0. Then we'll have 7, negative 6, 0, negative 9. Then we'll have a 10. So this is a squared. Then we'll multiply a squared with another a. So for us to obtain finally a cubic, so we'll have our a squared set, which is 9, 0, 0, So we're multiplying it with our A. So in short, the multiplication I'm doing for this time now is for A cubic, we're saying A squared multiplying with A. So that's what I'm doing here. So our A matrix was 3, 0, 0, then 0, negative 1, 3, and 0, 2, negative 2. So let's multiply. So 9 by 3 give us 27. Then 0 by 0, so these are the zeros, so we just have a 0 here. So the rest are zeros. Then we'll start with the 9 again with this column. So 9 by 0, it's 0. The rest are zeros, so it's 0 here. Then again we'll have 9 with 0, then the rest are zeros, so this is just 0. Then we go to this row with all the columns. So 0 by 3 is 0. 7 by 0, negative 6 by 0, so this is all 0. Then again this row with the next column. So we have 0 by 0, 7 by negative 1, we have negative 7. Then negative 6 by 3, that is negative 18. Then we go this same row with the final column. So 0 by 0, then 7 by 2, that is 14. Then negative 6 by negative 2, that is positive 12. So we go finally to the last row with all the columns. So 0 by 3, then the rest are zeros, so this is just 0. Then 0 by 0, that's 0. Negative 9 by negative 1, we have a positive 9. Then 10 by 3, that is 30. Then this row with the final column, so 0 by 0, then negative 9 by 2, we have a negative 18. Then 10 by negative 2, that is negative 20. And we have that, so we simplify it. So we're having 27, 0, 0. And we're having a 0 here. Negative 7 minus 18, that is negative 25. Negative 25, yes, negative 25. And then 14 plus 12, that's 26. And then we have a 0. Then 39, 9 plus 30. Then negative 18 minus 20, that is negative 38. So we have our element. So this one we found is our A cubic. Okay. So from the question, they've told us to show that this A cubic is equal to when we put this in place. So let's do it. So if we were to write 13A, so we need to find this. So let's first get 13A. 13A is us multiplying 13 throughout the A matrix, which is 3, 0, 0. Then we have 0, negative 1, and 3. And we also have 0, negative 6. Sorry, negative 6. 0, 2, and negative 2. So we multiply 13 throughout. So the 13 just multiply with each element. So 13 by 3, that's 39. So this is 0, 0. 13 by 0, negative 13. 26 here, 0, 39, negative 26. Yeah, so this is when we multiply 13 with A. Then we need to find 12i. So the identity matrix multiplied with 12. So our identity matrix is the one it's a matrix having 1 in the leading diagonal. So 1 and throughout the diagonal, the main diagonal. So we have this. So if we were to multiply this by 12, we'd have 12, 0, 0, 0, 12, 0, 0, 0, 12. Okay, so now that we've obtained the two sets, we can now put them in place. So that is, we're saying 13a minus 12i will be equal to, so our 13a matrix is 39, 0, 0, and then 0, negative 13, and 39, and then we have 0, 26, and negative 26, subtracting the 12i, which is 12, 0, 0, 0, 12, 0, 0, 0, 12. So with addition and subtraction of matrices, we just do with each element. That means 39 minus 12, that is 27. So this is now our final answer. So we'll have a 27 there. Then the rest are zeros here. Then 0. Then negative 13 minus 12, we'll have a negative 25. Then 26 minus 0, it's just 26. And then we'll have 0 there. 39 minus 0 is 39. And then negative 26 minus 12, that is negative 38. So if you look at what we've obtained here, we need to equate it to, is it the same with this? And of course it is. So our matrix has been, the equation has been satisfied. So we can just say hence the equation a cubic is equal to 13a minus 12i satisfied. It is satisfied, and we are done. So look at what we did. So the question was given, we need to show that this is holding. So we solved them independently. We solved this, we found the value of this, and we subtracted them, and we just equated just to see if they're the same. And since they're the same, we can conclude that the equation is satisfied. Let's go to the other part. The next part of the equation tells us that we should show that the equation in 1, which is this equation, can be written in this way, and then we should find the inverse of A. So that's the question we've been tasked with. So we need to write this equation in this format. So let's do it. So we'll take the equation as it is. A cubic is equal to 13a minus 12i. Okay. So let's try to multiply throughout the equation with A inverse, so that we'll have A inverse multiplying. We'll split A cubic to A and A squared, which is equal to 13A multiplying with A inverse minus 12 the identity matrix multiplying with A inverse. So if we multiply A inverse with A with its inverse, we'll get the identity matrix. And the identity matrix multiplied by A squared is just A squared, which is equal to, then A with A inverse will give us the identity matrix, and then minus A inverse with identity matrix, it will just be 12. We'll have the inverse matrix written. So from here, our focus is to make A inverse a subject. So we can rewrite the expression with 12 A inverse is equal to, then we'll have 13 minus A squared, like that. Then we can divide throughout by 12. Is that how the expression was? Yes. We divide throughout by 12, so that we have A inverse is equal to 1 over 12 multiplying 13i minus a squared. So we've written the expression as instructed. We were taught to write this expression, the equation, in this way, and then we were taught to find the value of A inverse. So now let's find the value of A inverse. So A inverse we're given is equal to this expression that we have. So since they've already told us that A inverse is equal to this, so this is first our expression we've done. So we can either use the formula of we get the adjoint, the determinant, and then we resolve it. So it's okay. Or we can just replace in the same expression written. So finding A inverse will give us, so A inverse will be equal to 1 over 12. Then 13 multiplied with the identity matrix, we just have 13, 0, 0, 0, 13, 0, 0, 0, 13. And then minus, so this, so a squared, remember we had solved for a squared, so we can just pick what we had solved. So a squared was 9, 0, 0, 0, 7, negative 9, 0, negative 6, 10. So this was our 9. Then we subtract the two expressions. So 13 minus 9 will give us 4. And then we have zeros here, 0, 0 here. 13 minus 7 will give us 6. 0 minus 6 will just give us 6. Then 0 minus 0 will just be 0. And 0 minus 9 will give us positive 9. Then 13 minus 9 minus 10 will give us 3. Then dividing through by with 12, so that means we'll have 4 over 12. So 4 there, 1, 4 into 12, 3. So we'll have 1 over 3, 0, 0. Then we'll have 0. Then 6 over 12 is 1 over 2. 6 over 12 again is 1 over 2. Then 0. Then we can reduce 9 over 12, that is 3 over 4. Then 1 over 4. Yes, and this is our inverse, A inverse. So this is okay. On our last question we have, for what value of beta does the matrix, this matrix written over here, not have an inverse? So if this matrix does not have an inverse, only if the determinant is 0. So that means we should find the determinant, and if it gives us 0, then it does not have an inverse. So let's find the determinant. So find the determinant for this matrix. We write D is equal to, so same method, we hold negative beta there, then and the column and the row. So we have 2 multiplying with beta plus 7, so that would be 2 beta plus 14. Then okay, something I've forgotten is we should have a negative beta outside there. Then so we've multiplied 2 with this, then we're subtracting with minus 3 beta. So 3 by beta there is 3 beta. Then again 3 multiplied by 3, there we'll have negative 9. Then we close it. So the next part again we'll have negative, then beta minus 1. This will be multiplying. So we hold this column and this row. We have 1 multiplying beta plus 7, so that is just beta plus 7. Then we have 3 with 3 multiplying 2 minus beta, which is plus 6 minus 3 beta there. So 3, okay, so this should be subtraction, since there's a minus, we're going to subtract. Okay, so we say this is 7, so there's minus 6. Yeah, since 3 by 2 is 6, 3 by, so this one will be positive due to the negative in between. And then we go to the last segment, so we hold this column and this row. So we have 1 by beta plus 3, that's just beta plus 3, minus, then 2 by 2, we'll have 4 there, and 2 by negative beta, so we'll have positive 2 beta because of the minus in between. And all this is being multiplied with beta plus 1, since it is the center there. Okay, so from here we can simplify. So we can reduce, we can work with what is inside the brackets here. So while having negative beta outside, we'll have 2 beta minus 3 beta, will have negative beta. 14 minus 9 will give us a positive 5. Then here we maintain the negative, then beta minus 1. We simplify what is inside here. So beta plus 3 beta will have 4 beta. Then 7 minus 6 will give us a positive 1. Then finally, saying plus beta plus 1 multiplying. So inside here we have beta plus 2 beta, that's 3 beta. Then 3 minus 4 will give us a negative 1. Then we can do the expansions. So negative beta minus beta, there will have beta squared. And then negative beta by 5 will have negative 5 beta. We proceed. We'll maintain the negative outside for now. So beta times 4 beta will have, so we'll have 4 beta squared. So 4 beta squared. And beta by 1 will have just positive beta. The negative 1 by 4 beta will have negative 4 beta. Negative 1 by 4 will have minus 1 there. Then expanding also the other side, will have beta by 3 beta will have 3 beta squared. Beta by negative 1 will have negative beta. Then 1 by 3 beta will have 3 beta there. And then 1 by negative 1 will have a negative 1. Then we simplify it again. So if this here will give us a negative 3 beta. So negative by 4 beta will have negative 4 beta squared. Negative by this negative 3 beta will have a positive 3 beta. The negative by negative will have a positive 1. In this other side, we're having plus 3 beta squared. Negative beta plus 3 beta will have 2 beta, then minus 1. We can collect like terms for simplifying, or we can simplify what can be erased. So we have 3 beta squared plus beta squared to give us 4 beta squared, and then there's a 4 beta squared. So these will subtract these 3. Then the 1 and the negative 1. Then 3 beta. 3 beta plus 2 beta will give us 5 beta. So this 3 beta plus 2 beta will give us 5 beta minus, so this will give us 0. So we're getting a 0 value here. So the value for beta that will make this expression be singular is when we have beta is equal to 0. So if we have a case of beta being 0, this matrix will be singular and don't have a determinant. We can prove it by replacing 0 wherever there is beta. So there it will just be -1, then we'll have 1, we'll have 1, 2, we'll have 3, then we have 2, then we have 3, then we have 7. Okay, so try to prove the determinant for this. Since we replace wherever there is beta, we've put 0. And let me know in the comment section if you managed to get 0 as a determinant. Thank you for watching. See you next time.